Welcome to the fourth lesson in Session 6 on solving quadratic equations using the quadratic formula. A quadratic equation is any equation of the form a times x to the second power plus b times x plus c equal to 0, where a represents the coefficient of the quadratic term, b represents the coefficient of the linear term, and c represents the constant. We'll learn four methods for solving quadratic equations. The first method is to solve by taking the square root. Solving by taking the square root is the recommended method to use when the value of b is equal to 0. The second method is to solve by using the zero product property. Factoring the equation is what allows us to use the zero product property and is the recommended method if the equation is factorable. The third method of solving quadratic equations is to complete the square. Completing the square can be used for any quadratic equation, but is most convenient when a is equal to 1 and b is even. The final method of solving a quadratic equation is to use the quadratic formula. Like completing the square, the quadratic formula will work for any and all quadratic equations. It is the last method and recommended when the other three methods are unavailable or inconvenient. In this lesson, we will learn how to solve quadratic equations using the quadratic formula. The first thing we're going to do is learn why the quadratic formula works. The quadratic formula is derived by completing the square with a quadratic equation in terms of a, b, and c. We learned that our first step in completing the square is to make sure that a is equal to 1 and subtract b to the right side of the equation. To complete this step, we need to subtract both sides of the equation by b and divide a by the entire equation. Our second step is to create a perfect square trinomial. The value of b in this case is b over a. Dividing it by 2 gives us the quotient of b over 2a. Raising that quotient to the second power gives us b squared over 4a squared. This is the number that we will need to add to both sides to produce a perfect square trinomial. Now we need to factor the left side of the equation and simplify the right. Factoring the left side will give us the quantity of x plus b over 2a squared. Finding a common denominator and simplifying the right side of the equation will give us b squared minus 4ac all over 4a squared. This is the point in the proof that the formula begins to take shape. The next step is to take the square root of both sides. The left side of the equation simplifies to x plus b over 2a. The numerator on the right side of the equation is not a perfect square and cannot be simplified. The denominator of the right side of the equation is a perfect square and gets simplified to 2a. Our last step is to subtract b over 2a to both sides of the equation. Since we are subtracting like denominators, we can write the entire expression as a single fraction. We are left with x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And this is where the quadratic formula comes from. While I don't think it's important for algebra learners to memorize the proof, I do think exposure of the formula has values. Now on to some examples. To solve using the quadratic formula, we have to substitute values of a, b, and c into the formula and evaluate. There are a few things we need to keep in mind on the road to a solution. We have to first set the equation equal to 0 in order to get true values of a, b, and c. Second, we always express our answer in simplified radical form. And lastly, just like completing the square, we should expect irrational and complex solutions. A rational solution indicates the equation was factorable at the beginning. So our first equation is read 2x squared plus 6x plus 3 is equal to 0. The given equation is equal to 0, so we are ready to begin our substitution by placing 2 in place of a, 6 in place of b, and 3 in place of c. Notice I have already completed some of the basic steps to begin my simplifying. The value of b has already been raised to the second power at the beginning of the radical, and 2 and a have already been multiplied in the denominator. From here, our complete attention goes to simplifying the radical. Negative 4 times 2 times 3 gives us negative 24. Subtracting 24 from 36 gives us 12. Our attention is still on the radical. We have to simplify the radical before we simplify the fraction. Simplifying the radical gives us negative 6 plus or minus 2 root 3 all over 4. Now that the radical is simplified, we can look to simplify the fraction. When simplifying the fraction, we are looking to see if the binomial in the numerator has a greatest common factor with the number in the denominator. The radicand is ignored at this point. We are focused on the negative 6 and the 2 in the numerator and the 4 in the denominator. Since all three of these numbers has a common factor of 2, we are allowed to divide out the 2 out of the equation. Negative 3 plus or minus root 3 all over 2 is the correct way to express the solution. In the next example, we first have to subtract 2 to both sides in order to get our true values of a, b, and c. This gives our constant value, c, equal to negative 2. Substituting those values into the expression gives me 5 plus or minus the square root of 25 minus 4 times 3 times negative 2 all over 6. Remember, all of our attention goes to the radical, so we take care of the multiplication and then we subtract, or in this case, since we have multiple negatives underneath the radical, they'll get multiplied and we add. After we complete that, we get 5 plus or minus the square root of 49 over 6. 49 is a perfect square, so as we continue to simplify that radical, we get 5 plus or minus 7 over 6. Now, that numerator is two different numbers. That's 5 plus 7 and 5 minus 7. 5 plus 7 gives me 12 over 6. 5 minus 7 gives me negative 2 over 6. 12 over 6 is equal to 2. Negative 2 over 6 simplifies to negative 1/3. So we have negative 1/3 and 2 as our solutions. Now remember, from the beginning of this slide, we said if you end up with a rational solution, then your equation was factorable. So I challenge you to take that equation and see if you can find those solutions by factoring. So move on to our last example. We have 7x squared minus 2x plus 4 equal to 0. My equation is equal to 0, so I already have true values of a, b, and c. So I take a is equal to 7, b is equal to negative 2, and c is equal to 4. Substituting those values into the equation and doing my preliminary evaluating, we get 2 plus or minus the square root of 4 minus 4 times 7 times 4 all over 14. Now as we simplify the radical, we'll notice we get negative 108 underneath the radical. So we need to simplify the negative out as well as simplify the 108. So we will have a complex solution for this answer. Simplifying the radical gives me 2 plus or minus 6i root 3 all over 14. Once I've simplified the radical, I look to simplify the fraction. My focus is on 2, the 6 from the 6i, and the 14. Notice the square root of 3, I cannot use the radicand for simplifying. The 2, the 6, and the 14 are all divisible by 2, so dividing the 2 out gives me 1 plus or minus 3i root 3 all over 7. And that wraps up the lesson on the quadratic formula. To earn credit for completing this lesson, you'll need to successfully complete the quiz. Good luck!